Hi, so this game is a simple auto battler in the style of Super Auto Bats. I've set two sides to fight against each other, and whichever side has members left standing at the end of a battle wins. So here we can see the class monster, and I have set attributes such as health and damage. And I have also set the monster enumerator to be the default value, which is max. I have also set various getters and setters in monster. Also, here's a constructor that sets the health and damage for monster class. Here we can see a child class. This is the class Goblin. It's a child of the monster class. Here we can see that it has its own attribute called number of attacks. Similarly, we see here the troll class. It has its own attribute called regeneration, and the special ability of the troll is that it can regenerate health once per turn when its health gets below its starting health. So we'll see the logic of that. Similarly, here's another child class. This one's called Orc. The power of Orc is that it can block damage and it can reflect damage. So when another monster attacks the Orc, it blocks the damage to the value we set here, and it also reflects some amount of that damage. So if we hop on down to the do battle function, this is the main logic of the code here. We see here that we pass these vectors of monster pointers. We pass those by reference. If we go down to the main function, you'll see why. So in the main function, I have these vectors of monster pointers initialized called red monsters and blue monsters. These are the vectors which hold the monster objects for each team. So if we go back to the do battle function, I pass these on by reference so that the changes I make here in the do battle function gets reflected in the main function. So here we see that I have set various pointers for each team, monsters and the subclasses, goblins, trolls, orcs, etc. This is the main loop of the program. If the red monster array has elements left in it, and the blue monster array has elements left in it, in Super Auto Bats, when the teams have members left standing, the battle continues. But as soon as one of the teams have no members left standing, the team is empty, the battle stops, and whichever side had members left standing would win. If neither of the sides had members left standing, it would be a tie. Here I've set the red monster pointer to the back of the array. So we get the back of the array for red monster and blue monster, and we point to that. Here's the main logic for the red team. So here we get the type of the red monster. In case it's a goblin, we do the logic for the goblin. The main power of the goblin is that it can attack multiple times per battle. So here I use a while loop and check that if it has attacks greater than 0. So I've set the attacks to the I've gotten the attacks from the goblin class and I've set it to an int. So if the attacks are greater than 0, it proceeds to do these checks. So for the first check, I check if the blow monster, so remember we're doing the red logic here, so if it's attacking the blue, we have to check for the blue monster. If the blue monster pointer is an arc, we have to check whether the blue monster pointer is an arc, so that the arc has special abilities which reflect damage and block damage. So if the blue monster pointer is an arc, we set the health accordingly. We get the blue arcs block, we get the blue arcs health, and we add those values and we calculate the health accordingly. Similarly, the arc reflects some amount of damage, so we also set that. Here, if I see red goblin dot set health, we see that some of the damage that the arc receives gets reflected, so I've set that back to the red goblin pointer. So if it's an arc, we do this check. Otherwise, if it's a troll or another goblin, we get into this check where it just damages the other monster and then proceeds. So after one attack's done finishing, we subtract the attacks and we keep doing this loop until it has 0 attacks left. So that's the check for the goblin. If you see the check for troll, it's very similar actually. So again, we static out to the block the damage. So that's why I put this check here. Otherwise, if it's a goblin or if it's another blue troll, we go to this else and then we get the damage from the troll pointer and then we subtract the blue monster's health from that troll pointer, from the damage of the troll. So lastly, for an arc, it's similar to the troll and the goblin. We check if the blue monster is another arc, and then if it's not another arc, we just do the damage function. And then that's the red logic. Again, the blue logic is very similar to that. Again, I check here instead of checking for blue monsters in the checks, I check for red monsters. So after all this, here, so this is the end of the turn basically. So here, I check for death. So if the red monster's health is below 0, or if it is 0, I initialize the check and reflect that accordingly on the console. Here I delete the monster pointer and I pop it from the array. So for the troll, remember that we had regeneration for the troll. So if we find that the type of the red monster is a troll and its health is not 0, it's above 0, we call this regenerate function. So if we hop on over to the troll class, we'll see that the regenerate function actually checks if the health of the troll is below the starting health, and if it is below the starting health, we have to add the regeneration of the troll to its health and pass it. So we do this minimum function so that it doesn't go above the starting health. So that's the logic for regenerate. So going back to the if check after the end of the turn. So yeah, so we call this regenerate function, and then the checks occur, and then if it does regenerate function, so sorry, I forgot about this. So if the red monsters array and the blue monster array are empty, if they're both empty, the battle is a tie. No team wins. If the red monster array is empty, the blue team wins. If the blue monster array is empty, the red team wins. So we keep seeing the show team composition function popping up. This one pops up here, this one pops up over here also, this one pops up here. So the show team composition function actually, again, it references these monster pointer vectors by reference, and then it loops through each vector. It loops through each vector. For the red monster, it loops from 0 till the size of the red monster, and then it shows the type and then shows the health. And for the blue monster, if we see it loops back, so that we get a style similar to Super Autopets, where the teams are shown from left to right instead of, from right to left instead of left to right. So the red team gets shown from left to right, and the rightmost value is the frontline monster. Here in the blue monster, the leftmost monster is the front monster. So the rightmost monster for red monster fights the leftmost monster for blue monster in a style very similar to Super Autopets. So here we see the cleanup teams function. So in this function, again we pass in these vectors. So this function is there to avoid a memory leak. We delete the objects from the red monster and we delete the object from the blue monster, and we clear the arrays. If we go down into the main function of the program, we see that we call the do battle and cleanup teams functions. Set the battle number to 1 at the beginning. In the do battle function, we increment the battle number each time a battle gets finished. So here we see various set pieces: goblin versus troll, goblin versus 2 trolls, etc. I've set various battles here, and after each battle we shouldn't forget to call this cleanup teams function, so that the arrays are properly empty and the pointers of objects are not there. Objects are deleted. So finally, I have written this random seed to push 4 random monsters into both teams. So I have set a rand index, and again using the rand index, we push either a goblin, a troll, or an orc. We loop through that 4 times, and we do that for red monsters, and we also do that for blue monsters. Again, we call the do battle function after that. Finally, we shouldn't forget to clean up the teams. Okay, so that's it for the code. Lastly, I do have a few improvements in mind for this. So scrolling back to the do battle function, here we for the red logic and blue logic, it's very similar actually. I just switched the pointers, and I just switched to the sides getting attacked. So this could be a basic function in the monster parent class, where you pass the opposing team's monster pointer as a parameter. So in the monster pointer class, in the monster class, there could be a function that does this without repeating it twice. So this logic gets repeated, red logic and blue logic. We just switch the. So here's a quick demonstration of the code. If we take a look at the final battle, it should be 4 monsters on each team. And indeed we see 4 monsters on each team. As I've said in the team composition function explanation thing, here we can see that the monsters fighting are facing against each other. See that the goblin and the orc fight. Here, when the red goblin dies, we see that the next goblin lines up to the front line and fights the orc.